move to the fifth part of this series, where we'll be looking at a very important subtopic under matrices. It is called the determinant of a matrix. We have our question here as gotten from our introductory video. The unknown matrix required to solve this question is matrix A, which is given as this. To solve this, let's break down our question into small parts, beginning with the first line, which states, if 6 in matrix A is replaced with an unknown K. So we have our matrix A as this, and 6 is indeed one of the values in the matrix as shown here. So we replace 6 with K. As we can see, K is occupying the same position in which 6 occupied initially. Now, if the next part had asked us to find just AI, we would know that we are dealing with matrix multiplication. But since we have these two strokes surrounding AI, we should know that these two strokes represent what is called determinants. It is important to note that you can only find the determinant of a square matrix, and the method for finding the determinant of a 2 by 2 matrix is different from the method for finding that of a 3 by 3 matrix. So we begin by evaluating what we have between the two strokes, which is AI. This is the matrix multiplication of A and I, where I represents the identity matrix. We have matrix A, which is a 2 by 2 matrix given as this. And for our identity matrix, we use the 2 by 2 identity matrix form, since A is a 2 by 2 matrix. Now we multiply. So if you use any of the three methods for multiplying matrices, as found in the matrices playlist on this channel, you should arrive at this, which is the same as the initial matrix used to multiply the identity matrix. Now, why is this so? Usually, when you multiply any square matrix with an identity matrix, you get back the initial matrix. For instance, if you multiply any 2 by 2 matrix like we have here by its corresponding identity matrix, you should get back the initial matrix. And the same applies for a 3 by 3 matrix. You should always get back the initial matrix. This is why the identity matrix is said to be like a mirror. It gives you back whatever you multiply it with. Now, since the method for finding the determinants differs for a 2 by 2 and 3 by 3 matrix, in this video, we'll focus on finding that of a 2 by 2 matrix. The basic formula for this goes as follows. Let's say we are given a certain matrix P as this 2 by 2 matrix consisting of letters A, B, C, and D. We find the determinant by multiplying diagonally, then subtracting. Now, this is what I mean. So we multiply the values on the top left and the bottom right, that is A and D, and place here. Then we multiply the values on the top right and bottom left, that is B and C, then place here. Then we subtract them to get the determinant of P. Now let's use this to find the determinant of AI. So for the determinant of AI, we multiply the first diagonal from top left to bottom right, which is 5 times K. Then we place here. Then we multiply the second diagonal from top right to bottom left, which is 1 times 3. Then we place here. When we subtract this, we should have 5K minus 3 as our determinant. Now, normally the determinant should have been a single value, but we have an unknown K attached here. That is why it is expressed in this form. Now, finally, the last part of the question asks us to find the new value of K if the determinant of AI is equal to 256. Recall that previously we got the determinant of AI to be 5K minus 3. So we equate 5K minus 3 to 256. And this becomes an equation that we should solve. To solve this equation, let's move minus 3 here to the other side of the equation, basically collecting like that. Of course, the sign changes to a plus sign as seen here. We add 256 and 3 to get 259. Now we have 5K is equal to 259. For K to stand on its own, we divide both sides by 5. 5 cancels 5 here. Then we divide 259 by 5 to get our new value of K as 51.8.
samurai sword on my back.